It was a night in October of 1933. Fritz Zwicky, a Swiss astronomer, was sitting quietly at the Mount Wilson Observatory. He had his eyes fixed on the Coma Cluster, a massive group of galaxies floating like grains of dust in deep space. Zwicky noticed that something was not right. Those galaxies were spinning around the cluster's center far too fast. If their movement relied only on the visible mass, then every single one of them should have flown apart into space long ago. But they were still there, not shattered, not off course. Zwicky furrowed his brow and softly whispered a phrase that would go on to haunt the world of astronomy: Dunkel Materie, dark matter. From that moment on, we began to understand that every calculation, every prediction, every law of gravity had been missing something massive and invisible. Decades later, a brave astronomer named Vera Rubin spent nearly her entire career tracking the motion of stars at the edges of the Andromeda Galaxy. She hoped to prove a simple idea that stars farther from the galactic center would rotate more slowly, just like planets farther from the sun move more slowly. But what she discovered completely shook the foundations of physics at the time. Those stars were not moving more slowly. They were moving far faster than predicted. If we only count the visible mass, Andromeda should have torn itself apart. There was only one explanation: a vast, invisible mass was holding everything together. A force we cannot see, cannot touch, but that is more powerful than anything we have ever known. Picture this. You are swimming through an ocean of black ink. Every flashlight you carry only lights up a few centimeters around you. But invisible currents are still pushing you forward, spinning you, dragging you deeper, even though you can never actually see them. When scientists pointed their telescopes deep into the farthest reaches of the universe, they realized something strange. Galaxy clusters were not just floating out there, they were stretching away from each other faster and faster. Once again, every known law of physics seemed to become outdated overnight. If the universe were made of only the matter and energy we already know, then gravity would eventually slow everything down. But instead of slowing, the expansion is speeding up. To explain that, scientists were forced to accept something that sounded like science fiction: dark energy. You can imagine dark energy as a kind of invisible pressure that fills all of space, constantly pushing everything farther apart. No one knows where it came from. No one knows whether... Tonight, in the slow rhythm of sleep's breath, I will tell you stories that very few people have ever heard. Stories that go beyond the boundaries of logic, of science, and even of belief. Because the universe is not just vast. It holds within it a kind of absolute indifference to our questions. You could spend your entire life searching for answers, but when you die, the universe will continue expanding, still challenging everything. Let me take you through the invisible door, a place where the line between truth and theory begins to blur. A place where every beam of light in the sky could be a message from a civilization that vanished billions of years ago. Or it could just be a cold candle, slowly fading in endless darkness. Are you ready? Take a deep breath and let your mind drift toward the infinite. We will begin with the simplest question, and yet the one that has never truly been answered. How did the universe begin? You have probably heard of the Big Bang, the moment everything exploded from a singularity, smaller than a speck of dust. A moment when space and time were born together, making every law of physics you know suddenly meaningless. But if there was a beginning, then what came before it? Was it emptiness, a place of perfect stillness, or perhaps an eternal cycle of explosion and collapse, repeating endlessly, never stopping? Science has no answer, and maybe it never will. When you think about the universe, imagine a giant oil painting made up of colors that human eyes cannot separate. We only see a few brushstrokes on the outer layer, and then we guess at the rest of the masterpiece. Every research paper, every massive telescope, these are just tiny magnifying glasses staring at a corner of that painting. Some people ask, if the universe is infinite, does that mean we are infinite too? Or is everything just an illusion, a brief dream inside a fragile mind, floating on a pale blue rock, drifting through cold, empty space. Tonight, you will hear about black holes regions of space where gravity is so powerful that not even light can escape. You will hear about wormhole hypothetical tunnels that could connect two faraway points in the universe in the blink of an eye. You will hear about dark matter and dark energy forces that shape the destiny of every star and planet, yet remain hidden behind an invisible curtain. And you will hear about the Fermi paradox. If the universe is so vast, with billions of galaxies and each galaxy containing billions of planets, then why have we not seen any sign of other life? You will begin to understand that the answer to that question does not just change the way we see the universe, it changes the way we see ourselves. Have you ever wondered whether we are not alone, but simply abandoned? Or worse, ignored because we are not important enough to deserve a reply? Let this night become a slow journey, drifting through the things no one fully understands, so that as you slowly fall asleep, your mind continues to float on the edge of knowledge and mystery. You do not need to remember everything. Just know that somewhere out there, billions of stars are still whispering nameless secrets. They are not waiting for you to discover them. They do not care whether you understand or not. But if you listen long enough, you will realize that your curiosity is the fragile thread connecting you to the rest of the universe. Close your eyes and let the story begin. If you have ever thought that science has already explained nearly everything, remember this: most of the universe is still wrapped in a dark veil no one has ever touched. We call it eternal darkness because even light is not enough to expose what is hiding inside. But what makes it truly frightening is not that we cannot see it. It is that everything, me, you, this planet, even the brightest stars, makes up only 5% of the total mass and energy in the universe. Everything you have ever believed to be reality is just a thin slice on the surface of something far greater, colder, and harder to understand. So, why does this topic matter so much? Because dark matter is not just a mystery to entertain you on a sleepless night. It is the invisible thread holding every galaxy, every star, every piece of matter together. Without it, the universe would fall apart. No large structure would ever have formed, and even you right here, in this very moment, would not exist to ask the question. Yet, even though it determines the fate of the entire universe, we still cannot see it, and we have never been able to hold it in any laboratory. Tonight, imagine you are walking across a faint, hazy bridge. Beneath your feet is an endless abyss of unanswered questions. All around you, countless dots of light drift by Aquan, a different theory about what this darkness really is. Let me tell you some of the heaviest stories ever discovered, findings that once left the brightest minds of humankind stunned, afraid, and in awe. You are listening to this while billions of cold lights are still silently burning across the night sky. But have you ever asked yourself, what exactly am I looking at? And how many things are still hiding in the dark right now? You might believe that the universe is nothing more than an empty void, stretching out endlessly. But the truth is 1,000 times stranger, because most of what exists, you will never be able to see. Tonight, I am going to take you beyond the edge of the known, straight into the heart of the greatest mysteries humankind has ever dared to ask. Questions that no one has ever answered. Questions that could keep you awake for a lifetime. But tonight, all you need to do is listen. Close your eyes and let your mind drift toward the stars that are waiting. Close your eyes and imagine you are standing alone in the darkness of night. In front of you, the sky stretches endlessly, dotted with millions of sparkling stars. They shimmer gently, quietly sending signals back to Earth. Signals that began their journey millions, or even billions of years ago. Have you ever wondered, what are you really looking at? Those bright specks are not just distant stars. They are remnants of supernova explosions. They are witnesses of colliding galaxies. They are the whispers of a universe older than anything we can begin to comprehend. There is a simple but terrifying truth. What you can see with your eyes makes up less than 5% of the total mass and energy in the universe. The remaining 95% is darkness, an invisible emptiness that has silently challenged human intellect for centuries. Have you ever heard of dark matter? It is everywhere, threading between the stars, wrapping itself around galaxies, holding the secrets of how everything is structured. But we have never seen it. We have never touched it. We can only sense it through the gravity of things that are not there. And that is only the beginning of the mysteries. It will fade away or grow stronger, but it is already shaping the final destiny of the entire universe. If dark energy keeps increasing, the day will come when the distance between galaxies becomes infinite. All the stars will fade out. The temperature of the universe will fall close to absolute zero. A silent eternity will settle over everything. That scenario has a name: the Big Freeze. Perhaps right now you are asking yourself, why should we care about things we cannot even see? Why spend billions of dollars and millions of research hours chasing something no one is even sure exists? Because dark matter is not just a mystery to entertain you on a sleepless night. It is the invisible thread holding every galaxy, every star, every piece of matter together. Without it, the universe would fall apart. No large structure would ever have formed. And even you right here, in this very moment, would not exist to ask the question. Yet, even though it determines the fate of the entire universe, we still cannot see it, and we have never been able to hold it in any laboratory. Tonight, imagine you are walking across a faint, hazy bridge. Beneath your feet is an endless abyss of unanswered questions. All around you, countless dots of light drift by, each one a different theory about what this darkness really is. Let me tell you some of the heaviest stories ever discovered, findings that once left the brightest minds of humankind stunned, afraid, and in awe. It was a night in October of 1933. Fritz Zwicky, a Swiss astronomer, was sitting quietly at the Mount Wilson Observatory. He had his eyes fixed on the Coma Clustera massive group of galaxies floating like grains of dust in deep space. Zwicky noticed that something was not right. Those galaxies were spinning around the cluster's center far too fast. If their movement relied only on the visible mass, then every single one of them should have flown apart into space long ago. But they were still there, not shattered, not off course. Zwicky furrowed his brow and softly whispered a phrase that would go on to haunt the world of astronomy: Dunkel Materie, dark matter. From that moment on, we began to understand that every calculation, every prediction, every law of gravity had been missing something massive and invisible. Decades later, a brave astronomer named Vera Rubin spent nearly her entire career tracking the motion of stars at the edges of the Andromeda Galaxy. She hoped to prove a simple idea that stars farther from the galactic center would rotate more slowly, just like planets farther from the sun move more slowly. But what she discovered completely shook the foundations of physics at the time. Those stars were not moving more slowly. They were moving far faster than predicted. If we only count the visible mass, Andromeda should have torn itself apart. There was only one explanation. A vast, invisible mass was holding everything together. A force we cannot see, cannot touch, but that is more powerful than anything we have ever known. Picture this. You are swimming through an ocean of black ink. Every flashlight you carry only lights up a few centimeters around you. But invisible currents are still pushing you forward, spinning you, dragging you deeper, even though you can never actually see them. When scientists pointed their telescopes deep into the farthest reaches of the universe, they realized something strange. Galaxy clusters were not just floating out there, they were stretching away from each other faster and faster. Once again, every known law of physics seemed to become outdated overnight. If the universe were made of only the matter and energy we already know, then gravity would eventually slow everything down. But instead of slowing, the expansion is speeding up. To explain that, scientists were forced to accept something that sounded like science fiction: dark energy. You can imagine dark energy as a kind of invisible pressure that fills all of space, constantly pushing everything farther apart. No one knows where it came from. No one knows whether it will fade away or grow stronger, but it is already shaping the final destiny of the entire universe. If dark energy keeps increasing, the day will come when the distance between galaxies becomes infinite. All the stars will fade out. The temperature of the universe will fall close to absolute zero. A silent eternity will settle over everything. That scenario has a name: the Big Freeze. Perhaps right now you are asking yourself, why should we care about things we cannot even see? Why spend billions of dollars and millions of research hours chasing something no one is even sure exists? The answer is simpler than you might think. Because if we do not understand dark matter and dark energy, then we cannot truly understand ourselves. From the very moment you were born, you have lived inside of it. Every planet, every star, every moment in human history has taken place in a universe ruled by that invisible darkness. Right now, as you are listening to this story, those unseen waves are still flowing through your body. They are the reason the sun stays at just the right distance far enough so the earth does not burn, but close enough so we do not freeze. They are still pulling galaxies toward each other, only to fling them apart again over billions of years. When you look up at the sky, do not just see the sparkling lights. Remember that behind that curtain of light is a kingdom of things we have never truly understood, a silent realm, but one more powerful than anything you have ever known. You might drift off to sleep as I say these words, but the truth will not disappear. When you wake up, dark matter and dark energy will still be there, waiting for the day we are ready to face them. And until then, every question we throw into the darkness is just a single drop in an infinite ocean of mystery. If you are ready, take a deep breath and let us step into the next great unknown. Black holes, regions of space that devour light, logic, and every definition of time itself. Do you believe that somewhere in the universe there are places where, if you step in, you will never come back? Not because you do not want to, but because time itself, space itself collapses behind you. Those places are real. We call them by two short, heavy words: black holes. The story begins with something that might sound familiar: the death of a star. When a massive star burns through all the fuel at its core, the gravity it once held back begins to take over. It collapses. It does not explode. It does not fade away. It folds in on itself, crushing its own mass into an infinitely small point. A point with no volume but with incredible mass. We call that point a singularity. Around that singularity, a region forms where anything that falls in can never come out. No light, no matter, no signal of any kind. That region has a boundary, a dividing line between knowing and not knowing. We call it the event horizon. Once something crosses that boundary, everything stops making sense. Imagine this: you are standing outside a black hole, watching a friend drift toward it. From your point of view, as they approach the event horizon, their time begins to slow down. A lot. Their clock almost stops. Every movement freezes. You watch, and you never see them cross that final boundary. It is as if they are suspended forever, right at the edge of nothingness. But from their perspective, something entirely different is happening. They cross the event horizon without even realizing it. There is no clear line, no warning sirens. Just the cold, unshakable truth: there is no way back. In the year 1974, a man named Stephen Hawking shocked the entire world. He said black holes are not completely black. They emit radiation, and then they might evaporate. That is how Hawking radiation was born. This idea shattered everything physics had ever believed. If a black hole can disappear, then where does the information it swallowed go? In our universe, information is not supposed to vanish. It can change form, but it is never lost. So, when a book falls into a black hole, where do all the words go? When a person, a planet, or even an entire civilization is swallowed, do their stories vanish, or do some traces remain? To this day, no one has an answer. Now, let us take a step away from black holes and enter a much more uncertain realm: wormholes. If a black hole is a bottomless pit, then a wormhole is a bridge. It connects two different points in space or even in time through a warped tunnel in the fabric of the universe. Picture folding a sheet of paper in half. Now, push a needle through both sides. You have just linked the two farthest points using the shortest path. In theory, this is completely possible. Einstein did not object. The math does not forbid it. But there is a problem. Wormholes are incredibly unstable. If you try to travel through one, you could collapse it just by being there. Only one kind of energy might be able to keep it open: negative energy. A form of energy we have never created, only speculated might exist. If wormholes are real and if we could somehow keep them stable, then maybe time travel would not just be science fiction. Imagine one end of the wormhole is in the year 2025. The other end is in the year 2095. When you pass through, you have just traveled across space and backward through time. But what if you went back and killed your own grandfather? Then you would never have existed to do it. And if you never existed, you could not go back and kill him. That is called the grandfather paradoxo of the classic thought experiments that has left physicists scratching their heads for decades. Does the universe have some kind of built-in rule to prevent that from happening? Or is time an unbreakable river, flowing forward no matter what? No one knows. In recent years, a new idea has emerged: the firewall hypothesis. It suggests that when something crosses the event horizon of a black hole, instead of falling into silence, it is immediately burned to ash by a wall of pure energy. If that is true, it destroys the foundation of general relativity. If it is false, then quantum theory is in trouble. The two greatest pillars of physics are clashing at the very edge of a black hole. And that forces us to face a serious question. Do we actually understand anything about the universe? Have you ever wondered what really happens if you fall into a black hole? Not sending a satellite, not watching from the outside, but you, your mind, your feelings slipping past the event horizon. Would you see your whole life flash in reverse? Would time rewind like a movie played backward? Or would it just be a total and something so final no language could ever describe it? Some theories suggest that at the center of a black hole, there might be a gateway to another universe, a place where time, space, and the very nature of reality no longer behave the way we know. If that is true, then every black hole is not an ending. It is a beginning. Black holes are scars on the fabric of space. Wormholes are strange folds in the structure of reality. And every question we ask about them makes reality feel a little more fragile. Maybe we were never meant to understand everything. Maybe it is that very not knowing that makes the universe breathtakingly beautiful. Just imagine, if you could see everything, if you knew every rule, if you could grasp the future and explain the past, would you still feel the urge to explore? Are you ready to step into the next chapter? Because when we talk about the beginning of everything, we are walking to the edge of time itself, the place where it all began. Close your eyes, take a deep breath, and let me take you to the very first explosion, the Big Bang. Imagine you are walking along an endless road. With each step, you flip through the chapters of the universe's history. Stars are born, galaxies collide, planets take shape, and finally, you listening to this in the quiet. But if you were to walk backward along that road, farther than light, farther than memory, farther than time itself, you would reach a point, a strange moment where there was nothing and yet everything. No space, no time, no atoms, only infinite compression. That moment has a name, two simple words filled with weight. The Big Bang. The first moment, an explosion unlike any other. The Big Bang sounds dramatic, but it was not an explosion in the usual sense. It did not explode into existing space. It created space itself. It was the eruption of reality itself. There was no outside the explosion. There was no before the Big Bang, at least, not in the way we understand time. The entire universe, every particle of matter, every beam of light, every law of physics submerged in a fraction of a millionth of the very first second. Imagine packing the whole universe into a marble smaller than the tip of a needle. Then that marble erupts, not just expanding, but carrying time itself along with it. There has never been a beginning more intense. No doorway could lead us farther than this one. The Planck time, where everything breaks down. You might ask, so what exactly happened in the very first instant? The answer is, we do not know. That first moment smaller than 10 to the power of negative 43 seconds is called the Planck time. In that instant, every known law of physics breaks down. There is no relativity, no quantum mechanics. We have no Lagrangiano equazione modelto describe what is happening. We only know that right after that moment, the universe expanded faster than the speed of light. This phase is called cosmic inflation. During that time, the entire universe ballooned from smaller than an atom to the size of galaxies in just the blink of an eye. 8. From fire to light, from light to matter. When inflation ended, the universe was unimaginably hot, billions of degrees Fahrenheit, or about billions of degrees Celsius, hot that atoms could not exist. It was a sea of plasma, a young universe, but a furious one. Gradually, the universe began to cool down. Elementary particles, like protons and neutrons, began to combine. Then came electrons. And finally, the first atoms were born, mostly hydrogen and helium. That crucial moment when atoms stabilized and light was able to move freely for the first time is called recombination. You can think of it as the very first dawn of the universe. Before that, light was trapped. But now, it began to traveling. It is still traveling today. We call it the cosmic microwave background, or CMB. And it is our strongest piece of evidence that the Big Bang really happened. The strange stand clearest proof. In 1964, two scientists accidentally picked up a strange noise through a radio antenna. They tried cleaning the equipment. They chased away pigeons. They checked every single wire. But the signal never went away. And then they realized they had just detected the oldest light ever recorded, the light from around 380 years after the Big Bang. That light is still echoing across the universe, like the first whisper from a show no one has ever seen. We were there in a material sense. Right now you are sitting, breathing, listening, and every atom in your body, carbon, oxygen, calcium, they all were once light. Then light became matter. Matter formed stars. Stars exploded. From the debris, planets were born. And then, you a tiny, curious being are here, wondering, where did I come from? You are the final result of a chain of randomness, collisions, explosions, and silence that began the moment the universe took its first breath. But what came before the Big Bang? And now, the biggest question rises again. If the Big Bang was the beginning, then what came before it? We do not have a definite answer. Some scientists believe time itself is a property of the universe, and if the universe did not exist yet, then the idea of before does not make sense. It is like asking, what is north of the North Pole? It is simply not a valid question. But there are other, bolder theories. The universe might be part of an infinite multiverse. The Big Bang was not the beginning, but just one moment in a never-ending cycle of birth, death, and rebirth. Or perhaps a parent universe gave birth to ours through a collision we can never observe. The edge of knowledge and the beauty of not knowing. This is the moment where you must face a hard truth. We do not know everything, and maybe we never will. Maybe those limits exist because of physics. Maybe they exist because of the boundaries of the human brain. Or maybe some things were simply designed to always stay out of reach. But within those limits lies a deep and quiet beauty. Because if we knew everything, what would be left to dream about? If every mystery was uncovered, what would there be to wonder about when we look up at the night sky? A brief look back at the journey. You have just walked through a journey spanning over 13.8 billion years, from absolute emptiness to the birth of the very first stars, from the first light to the breathing body you live in now. You are a strange and miraculous product of the universe, and that fact alone is a kind of miracle, an invitation to keep going. But this story is not over. Because if you thought the Big Bang was the beginning of everything, wait until the next part. When we ask, are we alone? Is someone else out there looking up at their sky at the exact same moment from a completely different world? Let that question carry you into the next chapter, the Fermi Paradox and the search for life beyond Earth. If you are ready, take a deep breath and keep dreaming.